Chapter 8, Exercise 8.45. You mix a 25.7 milliliters sample of a 1.22 molar potassium chloride solution with 14.3 milliliters of 0.870 molar lead-2 nitrate solution, and this precipitation reaction occurs. 2 KCl plus 1 lead-2 nitrate, we get lead-2 chloride and 2 potassium nitrate. You collect and dry the solid lead chloride and find it has a mass of 2.50 grams. Determine the limiting reactant, the theoretical yield, and the percent yield. There's a systematic way of determining the limiting reactant, which is to start from the number of moles of KCl and then divided by 2, we get the number of moles of lead chloride, assuming the other chemicals are in excess. And then we can start with the number of moles of lead-2 nitrate, and that's equivalent to the number of moles of lead-2 chloride, assuming all other chemicals are in excess. And then we get 2 different values for the amount of lead chloride, whichever is smaller. That's going to be the theoretical yield. The corresponding reactant is the limiting reactant. There's another way to do it, which is just look at the ratio between these 2 reactants. It's 2-to-1 ratio. So you can have the amount of potassium chloride by multiplying this and this. You can have the amount of lead nitrate by multiplying its volume and concentration, and see if the ratio is 2-to-1. If it's more than 2-to-1, then lead nitrate is the limiting reactant. If the ratio is less than 2-to-1, then KCl is the limiting reactant. So either way, you can get the correct answer. But now I'm going to show you the more systematic calculations to determine the limiting reactant. So first, let's look at KCl. What's the amount of KCl? It's 25.7 milliliters times 1.22 molar. Right, so we'll do this 25.7 times 1.22. And then we get 31.354 millimoles. So make sure you understand this value has a unit of millimoles. And because in the chemical equation there's a 2-to-1 ratio, so every 2 moles of KCl you get only 1 mole of lead-2 chloride. So I'm gonna just do this divided by 2. I got 15.677. Alright, so I have this number here. 15.677 is the number of millimoles of this lead-2 chloride, provided the amount of potassium chloride here, assuming all other chemicals are in excess. Alright, and then we'll do this one. We have 14.3 times 0.87, and then there's a 1-to-1 ratio. So let's do the calculation. I got 12.44 millimoles of lead chloride, and this value is smaller than the previous value from KCl. I think when I used the amount of KCl, potassium chloride, I got 15 plus millimoles, but now I got like 12.44. So 12.44 is the smaller value, and this lead-2 nitrate is the limiting reactant. Limiting reactant is this. Submit. Alright. Theoretical yield, we got it here. It's 12.44 millimole, or 0.01244 moles. And we need to convert it to grams, because over here it says gram. We look it up. Lead is 207, chlorine 35.5 times 2, because we have two chlorine atoms in the formula. We got 3.46. We got 3.46. So this is the calculation. So supposedly we can get 3.46 grams of lead 2 chloride. Theoretically, how much did we actually get? 2.5. So 2.5 divided by this. Alright, so if you do this, you get the percentage yield. But don't forget to multiply this by 100. Alright, so because 2.5 over 3.46 multiplied by 100% is gonna be the percent yield. Right, let's see if yeah, 72%.